All living things are based on atoms and their interaction with one another. And look at this as an example of a frog, unfortunately, fell into the trap of a Venus flight trap. And as soon as the frog does drop inside it, the Venus flight trap, it's going to close up and it entangles against the body of the frog. And after some time, we'll find that the frog will be dead. And the reason why it dies off is because of the chemical which the Venus flytrap releases that kills the frog before it digests the frog into its body system. So anytime you want to talk about organisms, predators and prey, we talk about chemicals. In fact, all organisms depend on many chemicals and chemical reactions for processes to happen in them. So whenever you want to talk about living things, you have to talk about chemicals and the interaction with chemicals, or the way the chemicals help to break down something or the other thing. So this is the reason why you cannot talk about biology, or you cannot talk about living things, except you have to talk about the interaction also with chemicals, and we have to talk about chemistry. An atom, as we know, is the smallest basic unit of the matter. Everything, anything you want to talk about a person, talk about animals, talk about cars, we have the same thing in common, and that's we have matter in ourselves. When you say matter, is something that has, for example, an atom. When you say something that has matter in it, it means what is contained in the stuff. The amount of something contained in something is called the matter. So everything that has mass and occupies space is called matter. So an atom is now the smallest basic of that matter. So if you have something which is called matter, now the smallest part of it is an atom. And an element is one type of an atom. For example, we have different types of elements. So an element is one type of an atom. And for example, hydrogen atom, oxygen atom. Now an element is one of the types of these atoms we've already had here. So an atom has some basic parts. It has a nucleus and it has an electron. The nucleus is broken down into two types or two parts. We have the proton and the neutron. As the name indicates, proton is got from positive, that is to say, it has a positive charge, while the neutron, as the name indicates, has a neutral charge, but the electrons, as the name indicates, has a negative, and that's the reason it's being called an electron. Electrons are in energy level outside the nucleus. If, for example, you have a nucleus used to be in the middle, and electrons will be the energy level on the outside. This is an example of a basic atom. Is an atom of oxygen. Now, looking at this is a nucleus, which is like the middle of the oxygen atom. It has 8 protons and it has 8 neutrons. In most cases, the number of protons used to be the same with the number of neutrons. And the only time when the number would vary is if the atom gains an extra charge. If an extra charge is got from another element or from another atom, it can help to increase or decrease the number of protons. That makes the number not the same. But in a neutral atom, in an atom which is not having more charges from anywhere, which is a normal one, it means it's going to have the same number of protons and the same number of a neutron. So, in most cases, the inner energy level of this used to take most number of electrons it can take is 2. So the innermost, like 1% is, this is the middle, and this is the This is the energy level, which is up to the middle of the what of the oxygen atom. So the highest number of electrons it can take is 2, and the one which is after it can take up to 8. Now, the way you write all these things is, now you've got to see that we have in total now we have how many number of electrons. The number of electrons we have in this atom is, you count from here, you count 1, 2, 3, 4, 5, 6, 7, 8. And if someone asks you what is the atomic number of oxygen, you tell him 8. And the reason is because you've got 2 electrons in the first energy level, and the one which is the outermost energy level is got 6 electrons. But we should understand that the highest number of electrons the inner energy level can pick or can carry is just 2. But for the outermost, it can carry up to 8, but for now it's having only 6. That is to say, we can have more of electron on the outermost shell to make it complete its 8. So, and also every element has its own name and has its own number of electrons. The atomic number of element is the number of electrons which is in it. For example, oxygen, we start from the first one, which is hydrogen, has 1, helium has 2, lithium has 3, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8. So if I decide to add 1 more, it's going to be fluorine. That means atomic number of 9. And if I add 1 more, it's going to be oxygen, fluorine is going to be nitrogen, which has atomic number of 10. So the meaning of what I'm saying is the atomic number of an element is almost like the same with the number of electrons which the element has. So now the next one says, it's talking about a compound. A compound is made up of atoms of different elements bonded together. The meaning is you're going to have elements which are not the same, which are different elements. You're going to have them being bonded together. So when atoms are put together, they form a compound. Example is water. Water has two elements, which is hydrogen and oxygen. They've been bonded together. So now what happens is they're bonded together with 2 atoms of hydrogen and 1 atom of oxygen. So that gives you water. This is a chemical representation of water, and we're going to talk about the bond when it's time. But for now, we just have to know that 2 atoms of hydrogen, which are positive, are attaching to 1 atom of oxygen, which is a negative. And also, carbon dioxide is a good example. And we have a carbon dioxide means we're going to have oxygen on the 2 sides, and 1 atom of carbon is having 2 atoms of oxygen combining with it to form a compound of carbon dioxide. And as the word indicates, carbon dioxide means 2 atoms of oxygen. We have many other carbon-based compounds in living cells, also living things. So let's talk about ions. When you say an ion, ions form when an atom gains or loses electrons. So the electrons, which I said to you before, which is, for example, let's say you want to draw the representation for hydrogen. Hydrogen could be represented by drawing, if you want to draw for hydrogen, which is the first element in the periodic table, has been drawn like this. Now remember that I told you that the first energy level, which is this is the nucleus in the middle. The first energy level cannot take more than 2. So this is the representation for hydrogen. So what for helium will be represented with the same shape, but here you're going to have 2 electrons in the first energy level, and this is the outermost shell for hydrogen and helium. And if you have another one, which is going to be lithium, for lithium, you have to draw another shell. The reason is because the highest number of electrons the first energy level could carry is only 2. So to have for lithium, you're going to have this shell, you're going to have 1 electron here. So sometimes it happens that this element can gain electron or can lose electron. For example, let's say you want to have a reaction between hydrogen and helium. It's either hydrogen gives its electron to helium or takes from helium, depending on some factors which we're going to be considering in the future. So, but the point I'm making is ions are being formed when you have when an element gains or loses electron. Let me give an example of what I'm saying here. Now, let's say we have hydrogen, and we know it has an atomic number of 1. And let's say you have 1, 2. Let's say you have lithium. So if lithium should give its electron to hydrogen, then hydrogen will have 2, and this will now become helium, because when it loses 1, it becomes the electron number becomes 2, and the electron number here becomes 2. So this becomes hydrogen ion because it already gained an electron. But this becomes lithium positive. Why? Because it already loses an electron. So this is what it means by ion is been made when an atom gains or when it loses electrons. So an ion is an atom that has gained or lost 1 or more electrons. We have positive ions. We also have negative ions. Ionic bond form between oppositely charged ions. When you have oppositely charged ions, they form an ionic bond. And what they're saying is this. Now, the reaction between sodium atom, which is this, like I told you before, sodium is represented by Na. It has an atomic number of 11, which is the number of electrons in it. So now let's count. This is a nucleus, and this is the first energy level, which got 1, 2 number of electrons. And the next shell, I told you before, can have a maximum number of electrons, which of 8 electrons. So now you're going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the last one, which is 11, cannot stay in the second energy level. You have to draw another shell for it to stay in. And that was the reason why it's here. So that's for sodium. And for chlorine, it's the atomic number of chlorine is 17. That is to say, it has 17 electrons in its shells. So if we count the number of electrons you have in it, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the third shell has 11, 12, 13, 14, 15, 16, 17. Now because chlorine needs only 1 electron to have a complete shell, so it means we made the shell to be complete. But this has only 1, and when it gives away that 1, then it's going to remove the shell because the shell has only 1. So the point is, sodium has 1, and it needs 7 more to live. But chlorine has 7. It has 7 in the outermost shell, so it needs only 1 more to live. So what happens is, sodium will decide that, okay, since I need 7 more, and this guy needs only 1, so let me give him so that he can live, and I will continue to live with my 2 shells without the third shell, because for me to go around and get 7 more is going to take a longer time. So let me give it to this guy who needs only 1, and is going to pay me. So we're going to form a bond. We're going to form a bond together. So that happens because if sodium doesn't give it out, it's going to take a longer time for sodium to have the complete shell because it needs 7 to have a complete shell. But for chlorine needs only 1 to have a complete shell. So that makes them to form an ionic bond. This is the reason, because when when it releases the electron in its outermost shell, so it becomes sodium positive. And when this gains electron, it becomes chlorine negative. So when it gains electron, it becomes negative. When it loses electron, it becomes positive. And now when they form a bond, they're going to form a bond of sodium ion and chloride ion, not chlorine ion. So this is the way ionic bonds are formed. Ionic bonds are formed between oppositely charged ions, that is to say, between a positive charged ion and a negative charged ion. I hope this is really helpful. So the next slide says, atoms share pairs of electrons in covalent bonds. In ionic bonds, what they do is they form together, they combine together to form a bond. I mean, they don't, for example, what I'm saying is, this is going to donate, is going to give away the electron to the other atom to form an ion, and this is going to form an ion. But in the case of the other bond, which is the hydrogen covalent bond is being formed when atoms share. Here, they don't transfer. They have to share it, so be very stingy. So it's like, I'm not going to give you my electron, and we have to divide it into two so we can both have it. So what happens is, we have different types of covalent bonds. We have multiple covalent bonds. We also have diatomic molecules. And an example of covalent bonds are the combination between carbon and oxygen. Carbon atom is the one in the middle. As we know, carbon has an atomic number of 6. And the way to know that is, if you want to form a representation for carbon, you draw the first shell, like you see here. It has a 1, it has 2, and the next shell, which can have a maximum of 8, is going to have only 4. You're going to have 1, 2, 3, 4. So that is to say, it needs 4 more electrons to have the outermost shell completed. And as a result of this, it could form a covalent bond. The reason is, oxygen has an atomic number of 8. Now let's count it. We will know by counting it. It has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 electrons. The number of electrons it has is 8. So that is to say, it got 2 in the innermost shell, and it's got 6 in the outermost shell. That is to say, it needs 2 more to have 8 electrons in the outermost shell. So due to this reason, it's going to be very easy for it to combine with another element, with another atom that has 2 also in the outermost shell. But because carbon has 4 and it needs 4 more, so it can form a bond with 2 elements that needs 2 and 2. So that makes it to form a covalent bond with 2 atoms of oxygen to form carbon dioxide. The meaning dioxide means 2 oxygen atoms forming together with 1 atom of carbon to form a covalent bond. So this is pretty easy. Once you understand the principle, you're going to be able to explain it to any length. So now the next one is that we can have multiple covalent bond. We can also have diatomic covalent bonds. But for this level, we will not be moving further beyond this level. So, and also we need to know the molecule. When we talk about molecule, the meaning is a molecule is 2 or more atoms when they've been held together by covalent bond. You're going to say you have a molecule when you have 2 or more atoms held together by covalent bonds. In like, for this is an example of a molecule of 2 atoms of oxygen and 1 atom of carbon. So, for example, we have a molecule of oxygen consisting of two oxygen atoms also that will pair the electrons. And almost all the substances that make up organism, from lipids to nucleic acid to water, are molecules held together by covalent bonds. So these are the information we have for you at this level. So we'll be talking more about the next stage when it's time. I really appreciate your listening. Thank you very much.